Welcome students, I am Sudipto Karmakar, Assistant Professor of Physics, Department of Physics, Swami Vivekananda Institute of Science and Technology. Today we will discuss about the topic quantum theory. Today's the chapter we are going to discuss is Blackbody radiation, the first chapter of quantum theory. In today's class we will discuss about what is Blackbody, what is its emissive power, what is absorptive power, and what are the characteristics of Blackbody or Blackbody radiation. So let's start. So the first question that came in our mind that what is Blackbody? Blackbody is any kind of object or any substance which can absorb all the radiations that is incident on it, and it can also emit all the radiations of all possible wavelengths when it is heated. A blackbody is a substance or body which can absorb radiations of all wavelengths incident on it, and it can also emit radiations of all wavelengths when it is heated. Now, what are the examples of blackbody? The examples of blackbody are lamp black and platinum black. These are two typical examples of practical blackbody. Why they are examples of blackbody? Because they can absorb radiations of all possible wavelengths up to 95% of the incident. That means if 100% radiation is incident on them, they can absorb 95% of it. So that is why they are typical examples of practical blackbody. Now one may ask that the name is blackbody, then what should be its color? Is it always black? The answer is no. The question that came in Macau in event semester in the year 2022-23. The question was, does a black body always appear black? The answer is no. A black body is not always black. In room temperature, that means when the temperature is typically low, in that temperature, the black bodies can absorb radiations of all wavelength, and thereby since they absorb all the radiations, so they will appear black. But as temperature increases, the black body is heated up, and thereby it will start emit radiations of all wavelengths. So depending upon the temperature, the black body will appear in various colors. So the answer is no. Black body is not does not appear always black. Now our second question is what is emissive power of black body or any substance? The emissive power of any substance or any body at a certain temperature for a certain wavelength is defined as the energy radiated normally to the vacuum from the surface per unit area, per unit second, per unit range of wavelength. That means from the surface of any body, the amount of energy or the amount of radiation it is emitted per unit area of the surface per second per unit wavelength range normally to the vacuum is defined as the emissive power of that body. Now, why for a particular temperature for a certain wavelength? Because the emissive power changes for temperature and also for the wavelength. So, to define the emissive power of any body, we first need to fix the temperature and wavelength. So that is why I have mentioned here at a particular temperature and a particular wavelength. Now, the next question is, what is absorptive power? The absorptive power of a body is defined as the ratio of the amount of heat absorbed by the body to the total amount of heat that is falling on it. And obviously for a particular temperature for a certain wavelength. So this is the absorptive power of the body. Now the next question is, what are the characteristics of black body, or what are the characteristics of black body radiation? The first characteristic is that the energy density that is the energy emitted per unit area per second from a black body, solely depend upon the temperature and not on the shape or size or nature of the black body enclosure. The second characteristic is the black body radiation is isotropic in nature. That means the radiation is equally distributed among the all possible directions. The next point is the black body radiations are homogeneous in nature, and the last point is black body radiations Now our next topic is what are the characteristics of black body radiation. Now the first point about it is the energy density of black body, that is the energy emitted per unit area per second, completely depend upon the temperature of the body. It does not depend upon the shape or the nature of the black body enclosure. The second point of the characteristics is black body radiations are isotropic in nature. That means they can propagate in all possible directions equally. The third point of the characteristics is black body radiations are homogeneous. That means the amount of energy that is spread over the all the directions is equal in value. And the fourth point is any body which is placed inside a black body enclosure can also emit black body radiation. So these are the 4 questions that we have discussed today. In our next class, we will discuss about the energy spectrum of black body and Wien's law and Rayleigh's law. Till then, keep learning. Thank you.